Okay, so this is test 3 review. There are 25 questions. I'm going to do all non-repeated questions. Okay, so let's start with the question number 1. It says select one of the following 4 sketches because the degree of the function polynomial is 3 and then leading coefficient is positive square root of 5. Then it's supposed to be like cubic function, which is up on the right side and down on the left side. So the answer is supposed to be D. Find the zeros of the polynomial function. Zeros can be found using this factor. X equal -5 makes this first factor 0 and x equal +5 makes this second factor 0. So 5 and -5 are the two zeros. The smallest zero here is -5, which has this exponent 4. That is actually gives you the multiplicity 4. And then from the second factor we get larger zero, which is +5, and then exponent on this factor is 1, so the multiplicity is 1. Find the zeros of the polynomial function and then again state the multiplicity. As you can see here, x plus 2 is repeated 3 times, so 0 from here is -2, and from x minus 3 the 0 would be +3. X plus 2 is repeated 3 times, so the smaller 0 has multiplication 3 and then larger 0 has multiplication 1. Once popular children's doll is slowly declining in popularity. The quartic function, this is the function you have given, where x is the number of years since 1993, can be used to estimate the number of dolls of this type that were sold in thousands during a given year from 1993 to 2003. Estimate how many dolls were sold in 2001. So the starting point is 1993. From 1993 to 2001, the difference is number of years. 1993 is 8 years. So put x equal 8 here, and then whatever value you get, that would be your answer. You can use your scientific calculator. So I'm going to use that here. 0.002 times 8 to the power 4. Okay, that's the first expression. Plus, now you have to use parentheses for rest of the operation, otherwise your calculator would not work properly. So for the second one, parentheses 0.025 times 8 to the power 3, parentheses close, minus, again parenthesis, 0.36 times 8 to the power 2, parenthesis close, minus, parenthesis, 7.243 times 8, parenthesis close, plus 86.993. So that's a 27. Round to the nearest thousand. It's a 27,000. Okay, that's these numbers are in thousands. If you look at here, where x is the number of years since 1993, can be used to estimate the number of dolls of this type in thousands. So it's supposed to be 27,000. If you multiply that by 1,000, it's 27,000. Round to the nearest thousand. So 27,000. Okay, just plugging the value after finding the value of x. A stone thrown downward with an initial velocity of 29.4 meters per second will travel a distance of s meters, where s of t, that's the distance function, is quadratic function, where t is in second. If a stone is thrown downward at 29.4 meters per second from a height of 132.3 meters, how long will it take the stone to hit the ground. So it's this is the distance. This function is the distance function. Will travel a distance of s meters. So this is the distance function from the height. What is that? 132.3 meter. And hit the ground means you have to make it equal to 0, because the distance is this distance from the ground. Let me see. Okay, so we need to find out, because look at here, the problem is there is something, let's say a building, and then someone is hitting a stone from here. The height of the building is 132.3 meter, and then that stone comes down here, and that curve can be modeled by using this function s of t. That's the distance. So the distance of this thing is going down is 132.3 meters. So we need to solve when this function s of t is equal to 132.3 meter. So put s of t, which is 4.9 t square plus 29.4 t equal 132.3. So we need to solve this quadratic equation. So because here is a decimal, one decimal, so we can multiply both sides by 10 to make this thing integer. So 49t square plus 294t, and then this is 1323. We need to solve this equation. Okay, so if because there is a decimal, we multiplied both sides by 10, and now there is a 1323, we can bring this 1323 to the other side, and this is the equation we're going to get. Before we solve this equation, try to divide these numbers by 49 if it's possible, and yes, you can divide by 49. 294 is divisible by 49, and this is also divisible by 49. So it will be t squared plus 6t minus, if I use a calculator, it's 27 equals 0. So now find out the two numbers whose product is 27, or use the quadratic formula and solve this equation. But I think I can find two numbers whose product is negative 27. So 9 times negative 3, positive 9. Oh, that's negative 27, but yeah, positive 9 times negative 3 is negative 27, but if you add positive 9 and negative 3, that will give you positive 6. So these are the two numbers, t equal negative 9 and t equal positive 3. These are the two values for which the quadratic function would be 132.3 meter. Time cannot be negative for practical use, so this is not possible. So the only possibility here is after 3 seconds, the stone hits the ground. So the answer is 3 seconds. So we can solve this type of problem by solving quadratic equation. Find the function f of x. For this function, find the maximum number of real zeros. Because the degree is 6, so the maximum number of real zeros could be possible is 6. And so real zero, they are also x-intercepts, so they're supposed to be 6 x-intercept maximum. And then turning points would be 1 less than the degree of the polynomial, which is 5. For this is a very similar question like question number 6, so I'm going to skip that. Go to the question number 8. Use the leading term test. So here the leading term is 1, the degree is 5. So the graph would be look like cubic function, up to the right and down to the left. And by checking all this graph, the only possible is D, because if you check this graph up to the right and down to the left, other than this graph, no one else has the same feature. So that is the answer. Use the intermediate value theorem, determine if possible whether the function f has at least one real zero between -7 and -4. So intermediate value theorem guarantees if the value of the function at a is opposite to the value of function at b, opposite in the sense of sign. So we can find out those value here. To find that value, you need to find the value of the function at -7 and the value of the function at -4. I'm going to use this calculator to calculate that. At -7, it's -7, sorry, that's not parentheses, -7, no, parentheses 7, and use this plus minus, that will be -7, parentheses close, and that's the cube, that's 7 cube, plus parentheses 3 times x square, meaning -7 is square. So -7 is square means 49, because -7 times -7 is 49. I'm doing that math in my mind. -8 times -7, so I write 7 and plus minus, -8 minus -7, so -11. After that, the answer is -151. So -151 for -7. For -4, it's a -4 cube plus 3 times -4 is square minus 8 times -4, -11. This is -64. This is 48, positive 32, -11. This two, if you add these two numbers, it would be 80, and then this two would be 75. So 80 minus 75 is positive number. So one is negative, one is positive. That's the reason intermediate value theorem guarantees that there would be one answer. So by 1 0, by the intermediate value theorem, the function has at least one real zero. The b is the solution because the value of the function f of a is 150, I guess. What did I get? 151. And value of the function at b is positive 5, I guess. Yeah. So one is negative and one is positive. Okay. For the function, use the long division to determine whether x plus 7 is a factor of f of x. So for to be a factor, the remainder is supposed to be 0. You can use long division or you can use synthetic division. It doesn't matter. So here they are asking for the long division. So I'm going to divide x to the power 4 minus 3x cubed plus x squared plus 3x plus 1442 by x plus 7. You can also divide this by synthetic division, no problem with the synthetic division. Okay, so because the higher degree is 4 and higher degree is 1 here, so I'm going to divide by x cubed, because if you divide x4 by x cubed, that is the value you get. So now you multiply this by x cubed. So x times x cubed is x to the power 4. 7 times x cubed is 7x cubed. And then you keep going like that. So that will be negative 10x cubed plus x squared plus 3x plus 1442. If you divide this leading term by x, that will be negative 10x squared. So that goes here, negative 10x squared. And now if you multiply this 2, that will be negative 10x cubed, negative 70x squared. Sorry, negative 10x cubed and negative 70, because 7 times negative 10 is negative 70. You have to change the sign and it will be cancelled. Here it will be 71x squared plus 3x plus 1442. One more time, divide 71x squared by x. That will be 71x. So that will be 71x squared plus 7 times 1 is 7. 7 times 7 is 49x. And then change the sign. It will be negative 494x plus 1442, and then if you divide the leading term by x, it would be negative 494, and then if you multiply that, that will be negative 494x negative, this is 7 times 4, it's greater than this number, so that is so that is 7 times 494. 494 times 7 is 3458. 3458. If you change the sign, this is gone, but this is not zero. This is still, there is a remainder. Remainder not zero means this is not a factor. So the answer is no. That's only can be found by finding the remainder. And the long division process, whatever I did, it's very time consuming. So if it's possible, use the synthetic division. Like here, synthetic division, it's easy. Write down the coefficient for this polynomial, which is 2, and then 7, and then because x square is missing, I have to put 0 for the x square, 2, and then negative 12. Whenever you see any term is missing with the power x, then you need to put 0 for that one. So here we are dividing by negative 3. If there is a plus, make it minus. Bring this 2 down. 2 times 3 is negative 6. Bring 1. If you combine this, negative 3 times 1 is negative 3. So negative 3 times negative 3 is positive 9. 9 plus 2 is 11. Negative 3 times 11 is negative 33. And this is 545. This is the remainder, which is negative 45. And this gives us quotient. So always write down quotient starting from here. 11 plus negative 3x plus negative 1 times x squared plus 2x cubed. So your quotient is 2x cubed, x squared, 2x cubed, and what is the rest of the value? 2x cubed plus x squared plus x squared minus 3x plus 11, and then remainder is negative 45. Remainder is negative 45. Very easy and less time consuming. Use the synthetic division, determine whether the numbers are 0 of the polynomial function. If 3 and negative 4 are the zeros, then whenever you divide this by these numbers, the remainder has to be 0. So I'm going to do that here. First, start with the negative 4. Write down the polynomial on the top, which is, because we need to divide this by negative 4, so write down their coefficient, which is 2. Okay, I have to divide it by negative 4. So write down the coefficient, which is 2, 3, negative 14, and 24. Bring it down. 2 times negative 4 is negative 8. It's negative 5. 4 times negative 4 times negative 5 is positive 20, which is 6. It's a negative 24. So remainder is 0. That means negative 4 is the one of the 0. What about 3? Let's see. We're going to repeat the same story here. 2 goes down. 2 times 3 is 6. 9. 9 times 3 is 27. 27 minus 4 is 27 minus 14 is 13. 13 times 3 is 39. So if you combine these two, this is not 0. It's a 63. Because this is not 0, this is not 3 is not the 0. So the answer is the number negative 4 is the 0, and then the value of the function at negative 4 is 0. But 3 is not 0 because the value of the function at 3 is 63. Okay? Okay, so factor the polynomial function this, then solve the equation f of x equals 0. So factor the polynomial function. So how do you do that? Here I can factor by using, can I do something here? Okay, to factor I need to find the zeros. I can use the rational zero theorem, and for that I have to use the factors of 15. Factors of 15 are plus minus 1, plus minus 15, plus minus 3, plus minus 5. These are the options. And the coefficient of x cube is 1, so the factors of 1 are plus minus 1. So if there is any rational zeros, then this is supposed to be potential zeros. So we start with the 1. A 1, that's not going to be the answer. Let's say negative 1. Yes. So if we check with the negative 1 and then use the synthetic division, 1 is the coefficient of x cubed, negative 7 is x squared, 7 is x, and 15. You bring down here. So negative 1, negative 8, positive 8, 15, and negative 15, that's a 0. So remainder is 0. So this is the leftover factor, which is 15 plus negative 8x plus x squared. So the factors of these polynomials are x minus 1 is one of the zeros. So x plus 1 and this one, because x minus 1 would be plus 1. So these are the factors, but you can factor this thing further. So we need to find out the two number whose product is 15 and sum is negative 8. So that would be negative 5 times negative 3. So x minus 5 and x minus 3, x plus 1. So these are the three factors. So the factorate forms are x minus 5, x minus 3, and then x plus 1. And zeros from this factor you can find. 5 is one of the 0, 3 is another 0, and then negative 1 is another 0. And all those information we can find using synthetic division and factor theorem. Okay, find the polynomial function of lowest degree. Lowest degree with a rational coefficient that has given number as a sum of its zeros. So 3 plus I is one of the 0. That means 3 minus I is supposed to be another 0. So the lowest degree term supposed to be, lowest degree function supposed to be 3 degree, because there are 3 zeros. So if you are just looking for find a polynomial, there are many polynomial, but if you are looking for just one polynomial, you can say the highest degree coefficient is 1, and then one of the 0 is x minus 1, another 0 is x minus 3 minus I, and another one is x plus 3 minus I. So these are the zeros. So if you expanded form, if you want to find out this thing in expanded form, then you need to multiply this two. So that is x minus 3 plus I. No. X minus, okay, so one of the 0 is 3 plus I, so x minus 3 plus I becomes 3 minus I. Another 0 supposed to be 3 minus I, because 3 minus I is the conjugate. So when you take the minus of that, that would be plus here. So x minus, so whenever you multiply that, you try to make the, look at here, x minus 3, x minus 3. So let's go. So that would be x minus 3 minus I, that's the one of the factor. X minus 3 plus I, that's another factor. And if you have this, like, you know, this is like a minus b and a plus b, you know, if you multiply them, it would be x minus 3 whole square minus I square. That's the product. So that is x minus 3 whole square is x square minus 6x plus 9, and minus I square means negative 1, that would be positive 1. So there is x squared minus 6x plus 10, and you distribute that with the x minus 1 plus 10. You multiply by x, which would be x cubed minus 6x squared plus 10x minus x squared plus 6x minus 10. So if you combine this x squared and this x squared, it would be x cubed minus 7x squared and plus 16x minus 10. So that is the polynomial in expanded form with this two zeros, and then there is another extra zero comes from the conjugate property. So the answer, one of the polynomial would be x to the power cube and minus 7x squared and plus 16x plus or minus 10. That this is one of the polynomials. Okay, there might be so many different polynomial, but this is one of the polynomial with the leading coefficient 1, positive 1. The potential zeros we can find by looking at the factors of 27 divided by the factors of coefficient of x to the power 5, which is 1. So basically the potential zeros are factors of 27, which is plus minus 1 and 27, plus minus 3, plus minus 9. So these are the options. Find the rational zeros and then other zeros of the polynomial function. So we can use this rational zero theorem for finding the potential zeros. Finding the potential zeros. Okay, so for finding the zeros of this function, we can do very similar. We can use the similar process like we did before. Using the rational zero theorem, we need to find out the potential zeros. For that, we need to find out the factors of 20, which is plus minus 1, plus minus 20, plus minus 2, plus minus 4, plus minus 5, plus minus 10. So these are the options. So we can start with the negative 1. Because I am positive 1, let's start with the positive 1, and if it's 0 or not, and then use the synthetic division. So I write the coefficient of x cubed, which is 1. There is x squared missing, so the coefficient of x squared is 0. Negative 21 is for coefficient of x, and 20 is the constant. You bring 1 down here. 1 times 1 is 1, 1 times 1 is 1, negative 20 times 1 is negative 20, it's 0. So 1 is one of the zeros, so x minus 1 is one of the factor. And then from here, which is negative 20, positive x squared, it gives us another factors. So that is the quotient. So you can factor this thing, which is x minus 1, and then x plus 5 and x minus 5, because 5 times negative 4 is negative 20, 5 plus negative 4 is negative 1, positive 1. So the zeros are 1, negative 5 and positive 4. Find the rational zero. The rational zeros are, what is that? There are only rational zeros, and they are this 3, which is positive 1, negative 5 and positive 4. So negative 5, positive 1 and positive 4. Positive 4? Yes, these are the 3 zeros. And then factorization of f of x, it's this is what they are asking you. X minus 1, x minus 1, x plus 5 and x minus 4. Let me double check. X minus 4, yes. The possible number of positive real zero from Descartes' rule, the possible number of positive real zero is you have to count how many sign chains are there. So start from positive leading coefficient to negative, which is one sign change. From negative to the positive, second one. From positive to negative, this is the third one. The possible number of positive zero is 3. That is the maximum. And for finding the negative possible zeros, you have to replace this x by negative x. That will be negative 2x to the power 5, negative 4x squared, negative x, and negative 5. Whenever I replace x by negative x and do the simplification, I see that there is no sign change. If there is no sign change, then maximum number of negative 0 is 0. Okay, what did I do wrong? I did impossible number of negative real 0. And did I do something wrong? I replace x by negative, so it will be negative, 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 and then there is negative. So negative to negative is no sign change, so that is 0. The possible number is positive to negative 1, 2, 3. The possible number of positive real zeros is, it could be 1 or 3. It could be 3, and then 2 less than 3 is 1, and then we have to stop there. So these are the two possibilities. You see that? Because Descartes' rule says the possible number of positive real zero is number of sign chains. That's the one option. And even number less than that sign chains. If you subtract 2 from 3, that is the one. Okay. Asymptotes. First of all, the vertical asymptotes comes from the bottom part, which is x equal positive and negative 2. And then horizontal asymptote comes from comparing the coefficient on the top and on the bottom, because the coefficient, the degree on the top is greater than degree on the bottom. That is 1 degree greater. That means it's a what is that called? Oblique asymptote. So you need to divide 6x cubed by x squared minus 4. Dividing this by x squared gives you 6x. So put that thing here. So 6x cubed minus 24x. And then you stop here because the degree here is 1 and degree of the divisor is 2. So the oblique asymptote would be y equal the quotient value, which is 6x. So the vertical asymptotes are coming from the bottom part, which is x equal to 2 and negative 2. And then oblique asymptote is y equals 6x. 6x. So this is the right answer, positive 2 and negative 2, and then oblique asymptote is 6x. So look at the graph for positive 2 and negative 2. So here you can see this is 2 and then negative 2. At 0, the value of the function is 0. Anything greater than 1, it's supposed to be negative. Anything less than 1, it's supposed to be positive. Anything less than negative 2, if you put it here, negative 3 would be negative on the top, and then positive. So that would be negative. That's right. So this looks right. This is not right because y equals 6x. This is not y equals 6x. What about this one? This is y equals 6x. If x is 2, the y is supposed to be 12x. This is 20. So it might be okay, I don't know. So but this one, if x is greater than 6, that's not one of the vertical asymptotes. So this is the only option we have, which has the oblique asymptote y equals 6x and the vertical asymptote 2 and negative 2. Find the vertical asymptote. X equals 3 is the vertical asymptote. X equals 3 because that makes the denominator 0 and there is no common factor. X equals 3 is the vertical asymptote. Determine the horizontal asymptote. Compare the degree on the top and degree on the bottom, which is same. So the horizontal asymptote would be y equal 4. The function has two horizontal asymptotes. No. The function has one horizontal asymptote, which is y equal 4 over 3. Be careful here. The 4 is the coefficient of x cube on the top and 3 is the coefficient of x cube on the bottom. List the domain and then x and y intercept. Domain is all real number except 0. So how do you write it? The domain is on the left side, this one, which is from negative infinity up to 0, and then on the right side from 0 to positive infinity. So everything else is fine for this function except 0. And then y-intercept means when x equal to 0, that is the y-intercept, but x equal to 0, this function is undefined, so the y-intercept, there is no y-intercept. Okay, the vertical asymptote comes from this factor on the bottom where x equal to 0 makes that undefined. So x equal to 0 is the vertical asymptote. Horizontal asymptote is, since the degree on the bottom is greater, then horizontal asymptote is always y equals 0. There is no oblique asymptotes because whenever there is a horizontal asymptote, no oblique asymptotes. So try to find out the vertical asymptote x equal to 0, and then so this is supposed to be the right answer because x equal to 0 and y equal to 0 are the two asymptotes, and this side the function is positive, this side the function is negative. This is the only option you have. What else? Did I miss something? The x-intercepts are, x-intercept means when the function is 0, there is no way you can solve it, so there is no x-intercept. For the function g of x, solve the inequality. To solve the inequality, first of all, you need to find what makes that function 0. So x plus 8 over x minus 3 equals 0. This thing, x equal to 3 makes the function undefined, so 3 is one of the critical points, and x equal to negative 8 makes the function 0, so negative 8 is another critical point. So we need to find out where this expression is greater or equal to 0. We know for sure at negative 8 it's 0, and then we need to check what happens here, here, and here, from negative infinity, from negative 8 to 3, and then 3 to infinity. So just take a testing point from here, let's say negative 9, and look at find out the value of the function at negative 9. The value of the function at negative 9 is negative 9 plus 8 divided by negative 9 minus negative 3, which is negative 1 divided by negative 12, which is positive value. So here the function is positive. That's what we want to find. Here pick 0, that would be negative because as you can see here, if you put x equal to 0 in the function, it will be 8 over negative 3, which is negative. Pick something greater than 3, which is, let's say, 4, then it will be positive. So our goal is to find out where this function is positive and 0. So it's a positive here, 0 is negative 8, and then positive here. So how do you write it? The solution set is, the solution is, use comma to separate answer as needed. The solution is, you need to use the, what is that called? Interval notation. So here it's a positive from negative infinity to negative 8, from negative infinity to negative 8, including negative 8. So that's why it's a bracket. And then what else? From positive 3 to positive infinity. So not including positive 3, union positive 3 to positive infinity. Solve the following inequality one more time. You need to solve 0 and then find the zeros, and then find the testing point like before. So I'm going to skip that. Question number 24, very similar question. So bring everything to the one side. So I'm going to bring x to the power 5 plus x squared minus 2x cubed minus 2 greater or equal to 0. I'm going to factor by grouping method. Plus x squared minus 2 is greater or equal to 0. X cubed is x minus 2. Is that clear? X squared minus 2 plus 1 times x squared minus 2 greater or equal to 0, or yeah. So first of all, bring everything on the other side and make it equal to 0 and solve for x. So that will give you x squared minus 2 times x cubed plus 1 equals 0. And if you try to solve it from here, x equals the square root of 2 and negative square root of 2 are the two solutions. From here, negative 1 is the only one solution. So these are the critical points, these are the zeros for this function. And we would like to find out where this function positive. Here, negative square root of 2, negative 1, and positive square root of 2. These are the 3 points. So we would like to check what happens to the left side and here. So from left side, let's say you pick negative. Remember, the function is, what is the function in factorate form? It's x squared minus 2 x cubed plus 1. Let's say pick something negative 4. Negative 4 square is a positive number and a negative number, so that would be negative. The multiplication is negative. From here, let's pick negative something negative 1.1. So negative 1.1 would be, this is the negative number, this is the negative number, negative is positive. And from here, pick something 0, so that would be negative. So we would like to find out where this function, this expression is greater or equal to 0. We see that at this point, the function is 0, and here, positive. How do you write it? We want to find out where it's positive or 0, right? So here it's positive, so that means negative square root of 2 comma negative 1. Do not include negative 1. Oh no, include negative 1, because negative 1 is also part of the zeros. So union, from here, let's say I pick 0, then that is not the part of the solution. From here, so this is positive, this is negative, and anything to the right side is also positive. So that is starting from square root of 2 to positive infinity. So the answer is from here, which is square root of negative square root of 2 comma, what is the answer? Negative 1, and then negative 1, and then union, and then bracket, positive square root of 2 comma positive infinity. Because on this interval, the functions, this function is either positive or 0. Finally, the last question, it's a fraction. So find out the LCD, multiply both sides by LCD, find the critical values. So for finding the LCD, you can find the factors on the bottom, which is x minus 3 and x minus 2. 3 times 2 is positive 6. Negative 3 plus negative 2 is negative 5. Greater or equal to 15 divided by x plus 3, x minus 3. You can bring everything to the other side. Before that, cancel the common factor 3. So it will be 1 over x minus 3, x minus 2, minus 5 over x plus 3, x minus 3 lesser or equal to 0. Multiply both sides by LCD. Here LCD is x minus 3, x minus 2, x plus 3. So these are the three factors. So if you multiply both sides by LCD, what is LCD here? LCD is x minus 3, x plus 3, and x minus 2. Multiply both sides by LCD. That gives you, for the first one, that gives you x plus 3. And from the second one, it would be negative 5x minus 2. So from the first one, x minus 3, and from the second one, 5 times x minus 2 is lesser or equal to 0. Look at here. If you multiply here by LCD, x minus 3 cancel out, x minus 2 cancel out. The leftover is x plus 3. Sorry, this is x plus 3. And then from the second one, x plus 3 cancel out, x minus 3 cancel out. The leftover would be 5 times x minus 2. So that's 5 times x minus 2. Make sense? So now, if you, there is, what is that? Because both of them have the same LCD, so that means it's x minus 2, x plus 3, and x minus 3. So if you simplify on the top, that would be x plus 3 minus 5x plus 10 divided by this, x minus 2, x plus 3, x minus 3, lesser or equal to 0. If you do the simplification on the top, it would be negative 4x plus 13. Negative 4x plus 13. So from the top one, it's a negative 4x plus 13. On the bottom one, it's a x minus 2, x plus 3, x minus 3, and we want to find out where it's negative. So from here, we can find the critical points by finding the zeros on the top, which is negative 4x plus 13 equals 0, which is, I do have 5. Okay, so if you solve for x is 13 over 4. So that's one of the critical value, 13 over 4. From the denominator, x equal to 2 is another one, x equal to 3 is another one, x equal to negative 3 is another one. So now you need to check what happens to this function on these intervals. So you have to pick the testing points. So from here, pick something, let's say negative 4. Before picking that, you have to be careful. On the top, you have a negative, 4x plus 13. And on the bottom, you have x minus 3, x plus 3, x minus 2. Right? And these are the testing points. Testing points are negative 3, positive 3, positive 2, and then it's 13 over 4. Yes, pick something from here, negative 4, maybe. Plug negative 4 here, it would be positive on the top, negative, negative, negative. So negative on the bottom. So this is the part of the interval. This one, negative infinity to that point, negative 3, is so negative infinity to negative 3, including negative 3, because they are also interested to find the 0. There, the function is negative. What happens if you pick something from here? Let's pick 0. If you pick 0, it's a 13 over negative 3 times negative 2 is positive. So it's a positive. Here is the positive. We don't want positive. From here, let's say 2.5, which is 5 over 2. So that is 10. Negative 10 plus 3 is positive 3. I'm doing calculation by plugging x equal to 2.5 here. So positive on the top, negative times negative is positive on the bottom. So it's a positive here. Okay? Positive here. One more time. Anything greater than 2 is, let's say, 2.5. 2.5 is 10, negative 10, 3. negative 2.5 minus 3 is negative 0.5. 2.5 minus 2 is positive. Sorry, it's supposed to be negative. Negative. And by doing the same thing here, 3 greater than 13 over 4, which is 4. So let's say 4. At 4, it's a negative on the top and positive on the bottom. So that is at 4, it's a positive. And let's say anything greater than 13 over 4, which is 5. 5 is negative on the top and then positive on the, so this is negative. So from here, if you look at the interval where the function is positive, which is this one and this one, which is negative infinity to negative 3. Oh, we're looking for negative, sorry, from negative infinity to negative 3. And then from 2 to 3, including 0, that is negative. And from 13 over 4 to positive infinity, that is also negative. Make sense? So 13 over 4 is 0, but this negative 3 is not 0. It's on the denominator, so we don't include this 2 and 3. Sorry about that. This 2, 3 and negative 3, they are coming from the denominator, so you don't include them. Well, the only value you include is 13 over 4 because that makes the top part 0. So what is the critical value? Critical values are negative 3, positive 2, positive 3, comma 13 over 4. These are the negative 3, positive 2. So the solution set, it's negative infinity to what is that? Negative 3 union. We're looking for the negative part. So this is the negative part. This is the negative part from 2 to 3. Do not include 2 and 3 because that makes the function undefined. There is a vertical asymptote you are going to find. And very last is include 13 over 4 because that's one of the 0 and go up to positive infinity. So that's supposed to be the solution. Okay, and that's all for this test review.